All right, so who here has seen a red moon?
Mm.
I mean, not just like kind of orange, but like
Yeah.
a deep crimson red moon.
Yeah.
This photographer, Marcella Julia Pace,
Sure.
she has this amazing photo of the moon that color,
Wow.
and she actually caught it
Uh,
after a volcanic eruption.
oh,
She's
interesting.
got all these other amazing photos of the moon too,
Oh.
and they're all these different colors.
Yeah.
Like she spent 10 years taking photos of the moon,
Yeah.
and she's got it in basically every color of the rainbow.
That's incredible. I mean, that really makes you think about the moon differently, right? Because we kind of, just think of it as this silvery white disk in the sky, but obviously there's a lot more
Yeah,
color.
it's like a celestial chameleon, right?
It is. It
The
is.
changing colors up there.
Yeah, it's really highlighting how our atmosphere is acting like this giant, colorful lens.
Right. I mean,
Yeah.
the moon itself isn't actually changing colors, right?
That's right. The
Yeah.
lens, the moon's surface is basically brownish gray.
Okay, but it was the science behind how it looks, all these other colors.
It's all about light scattering. Those tiny little air molecules in the atmosphere, they scatter the sunlight and they don't treat all the colors equally.
Okay, so is that kind of like how the sun looks redder at sunset?
You got it. Same principle.
Okay.
Blue light gets scattered more easily than red or orange. So when the moon is low on the horizon, its light is traveling through a thicker slice of atmosphere.
Right.
And we lose a lot of that blue, leaving behind those warmer colors.
I see. So that's how it gets like that orangey
Hurrah!
or even red color.
Yep, exactly.
Pace is a picture where the moon is blue and even purple.
Right.
So how does that happen?
So that's where things get even more interesting.
Okay.
Different types of scattering come into play. You've got Rayleigh scattering,
Yeah.
which is responsible for the moon's typical bluish-white hue during the day. But then you've also got Mie scattering, which happens when light encounters larger particles like dust or water droplets.
It's like our atmosphere is making this giant cosmic art project, just mixing all these different types of scattering together.
Yeah, and depending on what's in the air dust, water vapor, even smoke from wildfires, you get this incredible variety.
Wow.
It's like the atmosphere is painting the moon for us.
So pollution could actually make the moon look more colorful.
It could.
Wow. Never thought of it that way. But the atmosphere isn't just playing with color, right?
That's right.
Pace also has these pictures where the moon looks squashed or stretched out.
Yeah.
So what's happening there?
Well, think about those times that you've seen the moon looking unusually large or distorted near the horizon. It's because the density of Earth's atmosphere isn't uniform. It's denser closer to the surface.
Okay.
So as moonlight passes through those different layers, it gets bent, kind of like looking through a wavy glass.
So it's not actually changing shape. It's just the light is getting distorted on the way to our eyes.
It's a bit of a cosmic funhouse mirror effect. And that distortion can make the moon appear stretched out or flattened, depending on the angle of the light.
So basically, our atmosphere is messing with the moon in all sorts of ways, making it look all these different colors, different shapes.
Yeah.
I mean, this is totally changing how I see the moon now.
Yeah.
It's not just this static, silvery disk anymore.
Yeah.
It's like dynamic and colorful, and all thanks to our atmosphere.
It really underscores how our perception of the universe is always filtered through the lens of our own planet.
That's a good point. So next time you see the moon, don't just like
Yeah.
glance at it. No, let's take a look. What color is it? What shape is it?
Right.
There's so much more to appreciate
Why?
than just, just glancing up there.
And it makes you wonder, what other ways might our atmosphere be affecting how we perceive distant objects in space? Could there be entire celestial phenomena we're missing out on simply because of the way light travels through the air? Food for thought.